Hi, welcome to Maths Masters. Today we're going to look back at the foundation stage, and these are the necessary building blocks, the foundations for addition, and it starts with counting. If you do any work this week and you want to share it with me on Twitter, then I can have a look at it. Then put the hashtag Maths Masters or Marvellous Maths Masters, and we can have a look at each other's and share it on there. Or if you're in my class, you can email it to me. I've been busy this week making a YouTube banner. I hope you're impressed with that. It includes the maths mole, and we have the maths mole in class, and he struggles a bit to see. So what is so important with your maths is that you talk about your maths. You are talking about what is going on in your head, what is the thinking that is behind the maths that you are doing. And I'm hopefully going to show you that this week. I'm going to show you how to do maths, what is going on inside my brain as I think as a mathematician. So I want you thinking about describing what you're doing, explaining it, explaining what you did, but also justifying it. Why did you do it that way? Why not another way? Okay, and then we can see the different approaches going on there. So, think of the maths mole as we go along. We have here going to look at the foundations of counting. So, children need to know the number names, and one good way of practicing those is counting forwards and backwards. Then, we can think about what the number names mean, and this is called one-to-one correspondence, and it's when they count, it's knowing that the number is the name of the object they're pointing to. So we have 1, 2, 3, 4, 5. So they know that 1 corresponds to 1. They know that 2 corresponds to the second one that they're counting. It is a good idea to get children touching and lining up the things they are counting, because it avoids them making mistakes, such as counting the same one twice, and it also avoids them doing this 1, 2, 3, 4, 5, 6. If they touch them as they count them, they know that that is the one that they are counting. Counting doesn't just have to be real life. It can be as much as possible. Counting cars, counting Lego, counting knives and forks for the dinner table. But you can also get children to count in an abstract way. And this can be clapping, it can be putting coins, dropping them into a tin, letting them count the sound they hear, how many coins are in there now. They can count number of jumps, for instance. The next thing is that they can count forwards and backwards to larger numbers. It doesn't mean to say they've got to count that many objects physically, but counting forwards and backwards to the numbers prepares them of the names of all the numbers that we have. So from there, we have something called cardinality. Cardinality is knowing that when you count a set of objects, the last number that you count represents the total number of objects there. So for example, if we had some apples and we counted them 1, 2, 3, 4, 5, 6, the last number I counted, which is 6, is the amount of apples that are there all together. That's the total amount. Same with fingers on our hand, 1, 2, 3, 4, 5. We know there's 5 there all together. We don't need to recount them. Children at first will have to do that to get the confidence to practice in that. If they count as 5 fingers and you say to them, how many fingers did you just count? You might find they go 1, 2, 3, 4, 5 and count again. But with practice, you could say you just counted them. How many were there? And they can tell you that they know there was 5 because they just counted them and that was the last number they came to. Children also know, or begin to know at this stage, and learn that as you move objects around, that there is conservation of number. That if you don't add anything or take anything away from that number, the number is the same. So if we've got 5 here, if I move them around, I've still got 5. If I line them up, there is still 5 there. And so they know that the number hasn't changed, nothing's been removed, nothing's been added to it. The next thing is ordinality of numbers. So this is where numbers appear in relation to each other, where they are in a sequence. So often in running races, we have first, second, third. Children, when they're lining up, first, second, third, fourth. It's not always good to be first. You can talk about different times that when it is good to be first, when it's good not to be first. Our date system works in that way, first, second, third, fourth of the month that we're in. But there's loads of things you can do with ordinality. You can measure how high each of it is, who was the first, second, third, if you're ordering them from tallest to shortest. You can see who was first in a race or how many jumps you could do, things like that. One thing to mention there are some great resources out there to help you with thinking of games and real life practical activities you can do with children to help them with counting. You need to make it as concrete and as visual as possible before moving to abstract counting. There's a brilliant film TV programme called Numberjacks, and there's also a website called White Rose Maths, and they have, if you go on their reception scheme of learning and you click on the autumn term, they have lots of counting activities. So make it as stories, and they've got in their PowerPoint section at the bottom of that page, they've got different resources that you can cut out, and children can make stories with frogs in a pond or different fish in an aquarium, lots of stories they can make, which shows how they can count and they can make a story about it, which is great. The final thing I'm going to talk about today is suppitizing. Now, suppitizing becomes after cardinality, and it's where children can recognise a number in a set without having to count them. And this is necessary for us to build on for addition. So if you play a lot of dice games or domino games, children can become really good at recognising those numbers. A lot of us will recognise that it's 5 without having to count it, because we recognise that there's 5 there in that set. We know there's 5 fingers on this hand. We know there are 6 apples there without having to count them. And there's 8 dots on the domino without having to count them as well. This takes a while, and at first children might have to count them, but the more they practice this skill, they will become much more fluent and expert at just suppitizing, knowing straight away that that is the number of objects that are in the set. Okay, so we're going to leave it there for today. This is just a guide, knowing the vocabulary, knowing the basics of counting, which we need to go on to addition, which we will start working from suppitizing tomorrow. Thank you for listening.